Today I'm going to be doing a quick video about repairing or replacing the battery in my copy of Pokemon Silver. So a lot of these old Game Boy cartridges use their save data, they put it into volatile memory, which means that it has an internal battery in the cartridge, which if it dies, the game will no longer save data. So basically, after about 15-20 years, these games will no longer save because the battery inside has run dry and it's no longer saving any data, but it's a relatively simple fix to just open it up and replace that battery. So that's what we'll be doing today for Pokemon Silver, but this can be applied to a wide variety of original Game Boy games, and as far as I understand, some Game Boy Color games and Game Boy Advance games might have similar problems and require similar solutions. So basically, I'm just going to start by demonstrating to you the problem. So here I have a Game Boy Color. I'm going to boot it up. I'm going to run through as quick as possible and just try to make a save. So you see there's no continue option, it's just new game and options. So I'm going to start a new game, just go through this as quick as possible. So quickly save. Now that's saved, I'm going to power off. Just let it sit for about 5, maybe 10 seconds. In theory, I should just be able to do this immediately, but sometimes the capacitors inside have charge in them, and just better to let it completely run itself out. Turn the game back on, and you will see that it does not save my data. So you see there's no continue option. It's still new game and option, which means that if you were playing this game, you start a new save, you play on it for 30 minutes, an hour, play on it for some time, save your data and shut it off, you would come back to a completely blank cartridge. So that's basically what I'm trying to resolve today, is to fix this cartridge such that that's no longer a problem. The tools that will be required for this modification are, first of all, a 3.8mm security bit, also sometimes called a game bit. This is a pretty non-standard type of screwdriver, but it's going to be used for opening up the screw back here and getting the cartridge apart. Some solder and a soldering iron, and in this case I have a place to rest the soldering iron. Now this is a soldering iron that I just purchased. It's a relatively nice one, but you could get the job done with something as simple as one of these, which you can probably find for less than 10 bucks. So all this is necessary, and also this is the replacement battery. It's a CR2025 battery, and this one comes with the tabs pre-attached to the battery, and this is the type you're going to want to get because you cannot solder directly to the battery safely at home. So if you get the ones with the tabs pre-attached, you can just replace the entire assembly inside the cartridge, and you'll see that when I open it up. So that's everything that's completely necessary, but there are some optional things that will make the job easier and safer as well. So let's start with this. This is a little soldering cleaning station just to clean the tip of your soldering iron. A wet sponge will do the job as well. Here I have some flux. This is basically going to prevent oxidation and corrosion and just keep everything cleaner as I'm soldering. Some isopropyl alcohol will help clean off the flux, as well as some paper towels or Q-tips that you can use for applying the flux and cleaning it off. This is some copper braided wire, which is going to be used to absorb solder, excess solder, and take it away from the solder joint, as well as a solder sucker or a solder desoldering pen will do the same job. This can help. A multimeter can just be used for testing the dead batteries and live batteries to make sure that you're accurately diagnosing the problem and you're not fixing something that doesn't need to be fixed. A little pair of angled tweezers might help as well. And looking around here, that appears to be everything that is necessary. So again, all of these things are necessary for doing the repair, but everything else I showed you is optional and will make it easier as well. So I'm just going to start by plugging in my soldering iron here and letting it heat up while I take apart the cartridge. So the soldering iron just plugs in. I'm going to set it down on the rest, move everything to the side. Oh, also one thing that might be helpful is to have a little extraction fan to bring around the solder smoke, but I don't have one. I plan on getting one in the future, but for now, it's not necessary. A mask could help with that as well. So I don't really know what the right temperature for this is. I'm just going to be setting it at 400. degrees Celsius. From what I read online, that seems to be a reasonable temperature, but this is actually my first time soldering in quite a while, so I am going to be kind of learning as I make the video. Now, let's take the actual cartridge here and disassemble it. So, using the security bit, game bit, whatever you want to call it, lefty-loosey on the screw right here until it comes off. Make sure you save the screw, put it somewhere that it's not going to roll away. I'm just going to put it in this. Then this back should slide, or maybe the front, slides down and then out. And here you have the PCB board inside the cartridge. Now flip it over, take the PCB board, printed circuit board, out of the casing, take this plastic housing and put it somewhere safe. You don't want to damage it with the heat of the soldering iron. And this battery here is actually what's going to be replaced. So ideally, you want something like this to replace it with. And what I'm going to do is I'm going to take my multimeter and test these two components just to make sure that I've accurately diagnosed the problem. So I'm going to take my multimeter here, set it to the 0 to 10 volt range, and I'm going to start by putting, there should be a label positive and negative on this battery. Let's see if I can find that. I can't, but I believe this side is positive. So I'm going to put positive to positive, negative to negative. Let's see if I can get this in range of the camera. And you see we're getting a reading of around 3.5 volts, which is pretty much what we're looking for. So this is a fresh, good battery. And I'm going to do the exact same thing on the battery of the circuit board here and see if we get that same 3.5 volts. So this is the negative side, so positive, positive, negative, negative. And you see this is actually not reading at all. There is 0 volts coming from this battery. I'm gonna flip around just to make sure I got the polarity right. Yeah, no, I got it right the first time. 0 volts coming from this battery, which means this battery is not holding a charge. It is completely dead. They die after about 15 to 20 years, and this cartridge is probably about that old. So the goal is to desolder this battery. A lot of people will just pry off the tabs and tape it together, but that's not really safe or optimal. And I'm just going to replace it with an entirely new battery with the tabs pre-attached. So here we go. Again, this is my first time soldering in a while, so please do not be so brutal on me if I don't do anything right. I'm going to start by taking some braided wire and some flux, and I'm going to try to remove as much excess solder from these tabs as I possibly can just to start. So I'm going to take a Q-tip just so I can easily apply this flux. Here's the flux, here's the Q-tip. Just take a little bit, a little will do, not too much. Put a little bit on this end, put a little bit on the other end. If anything, I took too much, but better more than not enough. Put a little flux on each end of the terminals, each end of the battery rather, and put that aside. This is what I'm going to be basically heating through, and because this is a braided copper wire, the extra solder when it's in a liquid form should be able to flow up and through it. So here I have my soldering iron. It is holding at 400 degrees. And here we go. I'm going to try my best. Again, first time in a while, so cut me some slack if I don't do anything by the book. But here we go. See the flux melting. Trying as much as I can to not breathe in the smoke because it is definitely not something that is healthy to do. I can see the copper wire is getting tinned, which is exactly what I want. And I can see the solder being wicked away from the joint. Keep doing this, and this side almost came free. Now I'm just going to take my tweezers and I'm going to be applying a little bit of upwards pressure on the battery as I heat this joint again in an attempt to completely just remove this side of the tab. There we go. Almost. It's kind of tricky, but be patient, don't force it. Again, patience is a virtue. I also have a conical tip, which means I don't have that much surface area in contact with the board, which a chisel tip would probably be more ideal for this application, but I'm just going to work with what I've got. And try not to put too much heat on the circuit board because you can damage it if you do that. You know what? It's not really moving, so I'm just going to let it sit for a moment, or maybe readjust my position. Try to get closer to the center of the frame. I'm just going to move over to the next one, come back to this. I'm in no rush, and I don't want to put too much heat in one spot if it's not absolutely necessary. So, again, I'm going to put this copper wick. You see the silver part, that's where it's been used up. The copper part is where it hasn't. Go right to the other battery terminal, hold it down through the copper wick. That way the solder is drawn towards the heat through the wick and is absorbed into it. And when you see the wick starting to silver up, that means it's doing its job, it's absorbing. And when that is the case, I will pull it away. Again, I have a conical tip, which is really not ideal for this application, but I'm making it work. All right, so most of the solder seems to be removed from that joint. Again, taking my little tweezers here. Okay, so you see that side completely came off. Give it a second to cool down. And we go back to the first one. I'll try to take this one off as well. Holding it down, putting a little bit of upwards pressure as I heat the joint. This one is being a little bit finicky, but that's all right. Again, patience. I'm not in a rush here. I'll try holding it a little bit of a lower angle so that I can get more contact area with the thermal pad, or solder pad rather. There we go. So that's the battery removed. I'm going to take my soldering iron, rest it back here where it's not going to cause any damage, and see how hot this is, if at all. Not that hot. So this is basically the old battery that, that we removed, and I'm going to be replacing it with this one. Now, just one more test. I'm going to, again, take my multimeter here. It's still in the same 0 to 10 volt setting, and I'm going to see, this is the negative side, so I'm going to put negative to negative, positive to positive, and again, no reading from this battery. So it is completely dead, and this is effectively trash. I'm going to put it to the side for the moment, and I'm going to get the new battery ready. So this is the new battery, and if you can see, there, I need to make sure I get the polarity right. Now, it's actually kind of hard to tell on this, but I'm going to compare it to this one. The round side is negative, flat side appears to be positive. That would be right. Okay, actually I can see the positive mark. Let's see if you can see that. I can see the positive mark on the battery, but it's actually a little bit obstructed by the tab. But this side is positive, this side is negative, meaning this tab is positive, and this tab is negative. So I'm going to put it down, let's say, with positive facing away from me, and I'm going to look on the battery, on the circuit board rather, and see that the terminals here are also labeled. So here there's a little negative, so this labels the negative side. Here there's a little positive, this labels the positive side, which means that this needs to go back in this direction and not that direction. So I'm going to line up positive to positive, negative to negative, which is like so. And I'm just going to set it aside for the moment. There needs a little bit more preparation before I go straight into it. So first of all, I'm going to reapply some flux, a little bit to the board. Don't want to overdo it because any extra flux at the end I'm going to have to clean off with the isopropyl alcohol. And I'm going to take some solder, make sure that my soldering iron doesn't go to sleep. I believe this has a sleep function if you let it sit for too long. And I'm going to first just tin the end of my soldering iron a little bit, which basically means just put a little blob of solder on the end of it. Okay? And I'm going to take this same solder and I'm going to tin the battery contacts. Hold it there until I can deposit a small blob of solder on the contacts. Flip it around, do the same on the other side. Doesn't hurt to put more solder. Put a little more solder on this side of the battery contact. Be careful not to burn yourself. This is pretty precise application of heat. It's not really going on. So what I'm going to do is I'm going to clean the tip of my soldering iron. Careful not to damage anything with this cable. Sorry for this background noise. It's just some construction. Put some more solder on my soldering iron, and again, just try to tin this battery contact. Just because there's solder there does not mean it's properly tinned. There we go. You want it to see it's nice and wetted, it's flowing, it doesn't look like you drop a ball of something on a surface. You want it to look melted into the actual battery tabs. So here we have a tinned battery contact, and setting that down, put my soldering iron, and now I'm going to be trying to put it into place. So remember, lining up positive to positive, negative to negative. Here we have, I'm sorry if I'm out of frame. I'm going to scoot a little bit closer to the center. Positive to positive, so this end is positive, this end is negative, and it corresponds with the same ends on the board. So I'm going to set it down right here. Actually, you know what, before I do that, I'm actually going to try to even out the solder on the board a little bit and absorb anything extra, because there is a little extra solder, and if it's a nice flat surface, would be a little bit more ideal. So I'm just going to absorb that. That's better. The other one seems to look good. I'm ready here, I might as well do it. Absorb some solder here until the copper braided wire turns silver. That's how you know it's done its job. Seems to look good. I'm going to put a little bit of extra solder back on the tip of my soldering iron. Again, don't breathe the smoke. It would be better if I had a little ventilator system, or rather air circulator system, but I do not, and I'm just going to do what I can with what I've got. So, positive, always double, triple check this, because you do not want to hook it up with the reverse polarity. So this is positive, which means it should go like this. Now, just to prevent it from skirting around as I do this, I'm going to lightly hold it down with a small pair of tweezers. And here we go. I'm going to start on the negative contact, just apply some heat, and try to get it to melt and solder together. Just holding it there. Actually might be a good idea to put a little bit more solder. I don't want to have a dry joint here. Pull out a little more solder. Again, this stuff is pretty cheap, so you don't want to be, it's a fine balance. You don't want too much, but you don't want it to be dry either. Here, it's looking like we're getting somewhere. Right. That appears to have joined. I'm just gonna give it a little push. Yep, that looks good. I'm gonna flip it around, do the other side. It would have been a good idea to put more flux, but it's not a big deal. Well, this one went pretty easy. That looks already well done to me. Now, again, I'm gonna put my soldering iron just to rest in a place where it will not burn me. And here we have the circuit board, and it appears to have made, see, the positive looks good, but the negative could be better. I'm actually gonna go back and try to get some more heat on that negative end. Again, it probably would work already as is, but I'm already here, I'm already got it opened, and I would just rather do the best job I could. Alright, that looks about good. Now it's the moment of truth. Now we got to see if this actually works. So it appears that I have successfully resoldered a battery. It doesn't have any wiggle room, which means that both ends are firmly attached. And now time to reassemble. So take the back half of the cartridge and drop it in. Make sure this little screw post in the middle lines up. Take the front half of the cartridge, set it in a little bit, the little gap on the top, and then slide it forward. Then in the back, take the screw from before, drop it in. Take your security driver or game, I'm not sure what it's called, security bit or game bit, I believe. Screw it in. You don't want to over tighten this because it is screwing into plastic and you can strip the internal threads. So just give it a nice little snug. Move this to the side and let's see if it works. Moment of truth. It's turning on, it's a good sign, but that's not really the problem. The problem is saving. So let's see if it saves. So there's no save currently, and that's obvious because we just repaired it and there was no save when we checked at the beginning, but I'll make a new save game and give it a shot. Actually, yeah, I'll just go. I was thinking about actually starting my real save game and putting in all the good information, but I'll just reset it when the video's over. So, just for a little proof of concept, I'm actually gonna hold it up a little bit closer to the camera, see if I can get some light on it, because these Game Boy screens are not very, oh, that's much better, okay. Hopefully the audio is not much louder now that I'm right close to the camera. Actually, I can probably just get back, yeah, it works. Alright. Sorry if the screen at the beginning of the video was not easily visible. Crossing my fingers that this is going to work. But again, this is not really something I'm sure about, so kind of learning as I go. So I'm making a save state. Save the game. Turn it off. I'm going to let it sit for maybe like 5 seconds or so. Make sure if there's any capacitors in the circuit board, they've discharged. Turn it back on. And here's the moment of truth. Let's see if I have a waiting save state for me. Yep, so here it says, now I have the option to continue, not just a new game. So if I hit continue, you will see that I have saved. I don't have to go through that entire boot up and start the new world process. So this has been a success. Thank you for watching, and I hope I taught you something. I definitely learned something.